Thank you. Good afternoon, everyone. Welcome once again. So, I'm Praveen Kumar from Sassen Technologies, and I will be actually talking about Nessum technologies, how it can actually fit in flat environment. Little bit, little bit apartment use case also I will discuss, but main focus will be in flat environment, how what all use cases it can actually where all it can be used. So the agenda, yeah. So I will be talking little about theoretical part, which is already covered by JP and Mrs. Han. Then main focus will be in apartment environment, where all it can actually in which all use cases it can be used. Then individual flat environment use cases, a little bit theoretical file layer, Mac layer details, which can actually help you understand its features, capability, and limitations, if any. Then I will share the test setup which we actually created in our office. Uh, so that's the test setup, and then the performance, what we actually saw. So yeah. So as actually already discussed by JP and Mrs. Han, see this PLC, as names suggests, here power line, the existing electrical wires are used as a data network. So no need to actually lay down another actually cables for data network. Mainly it has actually two categories, narrowband and broadband. And Nessum is actually comes under broadband. Also, we say HD-PLC. So here data rate can actually go up to 1 Gbps. Narrowband, which was actually earlier designed, it supports. There are actually standards like FCC, ARIBs are there, uh, which has actually different channel bandwidth, and it can actually support data rate up to 1 Mbps. But there are many applications which needs a higher data rate. So NESM is very much suitable for that. Nessum it is included in IEEE. So IEEE 1901 as JB showed, there are actually multiple amendment 1901 A, B, C. So 1901 has actually again different file layer. One is FFT based and another is wavelet. So NESM actually supports wavelet based. So we will be discussing. So the applications, which is actually for the use cases for apartment environment. Smart meter is definitely one use case, and it is already installed at multiple places. Uh, Millions of actually nodes are already in Europe and Japan. It has been installed, and NESM has actually already proven its capability there. Another use case could be building management, so controlling light, HVAC, security. So because it is uses existing electrical wire, so anything which is on connected with electrical wires, there it can be used. So building management is definitely a use case. Then elevator monitoring, so remotely it can be actually monitored and controlled. Then common area access control. So here also means controlling the gate, then parking, monitoring the parking area, video surveillance. So all that actually, because it supports up to 1 Gbps, all are actually feasible with NESM technology. Also, for critical application like access control or emergency system, we should have actually multiple communication channels, because these are actually critical applications. So multiple channels would be better. So definitely PLC will be actually one option. So another actually use case could be actually solar and renewable energy management. For individual flat application, so a smart home application. Nowadays, means all the appliances are actually connected through electrical wire. So, and if it has actually if supports a PLC, then all the means home automation will be actually very much suitable for this technology. Means using if we'll go with wireless, so wireless can actually create, sometimes it can create blind spots, or some in some cases it will be signal will be very weak. Then PLC can be actually a substitute for that. So a smart home automation, then IP streaming, IPTV streaming. Uh, so normally for any video streaming, SD video also it can actually it can take up to 8 to 12 Mbps, and this Nessum can actually support in file layer it supports up to 1 Gbps, but at Mac layer even if it is actually 60% of it, it will be very much uh, suitable to stream IPTV. Uh, then home office network, yeah. So Wi-Fi can actually have zones where it signal will be very weak. So their PLC could be an option. Then in-home health monitoring, any device, as we know, any device, if it is connected to electrical wire, IC could be the very good option for that. So home security, cameras, motion sensors, all could be actually connected using PLC. Uh, Cameras, yeah. So since it actually supports a very high data rate, multiple cameras can also be supported using PLC. Uh, Smart kitchen appliances. So if the appliances has actually PLC support, then it could be actually controlled remotely. So even if like in home automation, light and fan control, uh, you need not have all the appliances connected, means PLC support, means switchboard can be actually enabled with PLC, and then through switchboard itself, if we have to just switch on or switch off, it can be actually uh, controlled using PLC. So one gateway with one side actually Wi-Fi and another side PLC, then whole home can be actually automated using PLC. So very good option to actually, PLC is very good option for this home automation. So another applications like a smart home already discussed. It has already Nessum has already proven its capability in Japan and Europe. Uh, then in building high speed network, so it has actually multiple channels from 31.25 was can be actually divided into four. So short range around 7.8, then 15 could be actually used for long range, and other if it is actually 31.25 or double of 8, if we'll do 31.25 or 4, if we'll take then high speed, it can actually data rate we can it can be supported up to 1 Gbps. So Nessum is, if you compare with other technology, Nessum really actually is much better option. Then home automation, it can actually support up to 1024 devices. So definitely it is actually suitable for IoT kind of applications. street lighting, as we discussed, this it supports multi-hop. So up to 10 hops it can actually supports, which can actually range up to means multiple kilometers. So street lighting uh, can also be means, use case for this. Uh, Havoc and light control already we discussed. So retrofit installation, as we discussed, in existing installation itself, if we can actually, if the appliance has to just control switch on or switch off, then it can be actually, the switchboard can be enabled with PLC, and a gateway with Wi-Fi and PLC, then all the appliances can be actually controlled and yeah, controlled and monitored. Then other, yeah, IP surveillance cameras, yeah, multiple cameras can be actually supported. Then electric EV vehicle charging could be yeah, one use case for this. Yeah, so little bit about its a file-layer specification. So it is actually, it supports a wavelet OFDM. In 1901, there are multiple FFT-based OFDM and wavelet. Nessum is based on wavelet OFDM. Then it also supports multiple channels from 2 to up to 125 megahertz. Uh, then it actually supports different modes as well, like single in, single out, multiple MIMO also it supports. So you have multiple wires like earthing, then neutral, uh, so multiple on multiple wires also signal can be transmitted and received. So it can be actually MIMO is also supported. Then multi-hop, we already discussed up to 10 hop it can actually support. Then there is actually error correction, and security is also included in the standards. So even if it is a flat environment where multiple flats will be nearby, security is important. So includes it's a with AES support, it actually creates a separate zone for each flat. So other flat will not able to interfere or uh, each flat will be secured. So that way it is very much suitable for flat environment.
Praveen, sorry to interrupt. You have 2 minutes left.
Okay, okay. So yeah, then I will actually skip this because it's already discussed. So in my clear means multi-hop and all. Okay, directly I will go to the test setup which was actually created in our office. So we mimicked actually two flat environment, and each had actually three-phase electrical wiring, and we had actually we wanted to test how much actually there will be data loss when we have electrical equipments like MCB, energy meter, junction box, and then if there is some induction circuits like a stabilizer, voltage stabilizer, then we had actually tested with a different cable size as well. So what we actually, so this is the circuit which we had actually created. What we actually observed that in the fine layer, 111 Mbps, but MAC layer, we could achieve up to 54 Mbps. The path loss due to energy meter was actually 4 to 5 Mbps. And at MAC layer, it was actually, there was a drop of 10 Mbps. We also tested between different phase. When we tested with R and R, compared to R and Y had actually another 2 to 3 Mbps loss, and R and B, there was further 5 to 6 actually Mbps loss. When we similarly with energy meter and MCB and RCCB, there was further actually there was a loss from 6 to 8 Mbps. And it's we can understand that R and Y and R and B, yeah, with R and B being actually little further, means R and Y mostly they will be adjacent. So there was further loss when we actually tested the data exchange between R and B. But yes, it was actually means we were able to transmit data on R and we could able to receive on B. So those things we wanted to actually test, and we saw that it is all means it supports and it works in such environment. When we tested in actual flight environment, so within a room, we saw that we could achieve data rate, max layer data rate up to 44 Mbps between the rooms. When we actually tested with adjacent flat, so there also there was actually we could able to transfer data, but the data rate was low. So other observation was there was actually between the phase there is actually loss 2 to 6 Mbps of data rate loss. Voltage stabilizer didn't have much actually impact on the data rate. Within flat, it was actually very good. Within, so if it is a very near in the same room, up to 54 Mbps, but when within flat, easily 30 Mbps is achievable with multiple junction box and different phase.
Praveen, may I ask you to go to the conclusion? Sorry
Yeah, so
for this, but
this
yeah.
actually concludes. Yeah.
Oh, perfect.
Thank you.